Alright, in 10 and 11 here, it says to use a special right triangle to find the following. So let's start off and find 10. So whenever we do sine, cosine, or tangent, it's always got to be in a right triangle. So I'll draw a right triangle here. And it says the sine of 45, which means we need a 45-degree angle. So I'll make that one 45. Well, by default, this angle also has to be 45 because they have to add up to 180. 45 plus 45 plus 90 adds up to 180. Alright, so remember, the sine of 45 is the ratio of the opposite leg over the hypotenuse. And the hypotenuse is always across from 90. So every 45, 45, 90 triangle is similar. And the ratio of the sides is going to be x, x, and x root 2. Alright, now if we want to get specific, we can make up a side length. We could say, alright, let's say this leg is 1 unit long, and that leg is 1 unit long. Then this leg is also going to be, well, that leg, the hypotenuse is going to be root 2 units long. So if we do the sine of 45, it's going to be the ratio of the opposite leg over the hypotenuse. So it's just going to be 1 over root 2. So that's acceptable. You could rationalize it by multiplying the top and the bottom by root 2, and you get root 2 over 2. Alright, you can also put it as a decimal. And if you divide root 2 divided by 2 on the calculator, you get 0.707. So that would be the answer as a rounded decimal. Alright, so you can use any 45, 45, 90 triangle side lengths and you'd get the same answer. Like even if you made this side like 200, let's change up the colors for a second. Let's say this side was 200 feet long and this side was 200 feet long. Well, then the hypotenuse would have to be 200 root 2 feet long. So the sine of 45 would still be the opposite leg, 200, over the hypotenuse, 200 root 2. Alright, and this would simplify to 1 over root 2, which is the same answer that we got for the smaller version of the triangle. So, you just need like one type of triangle with these angle measures in order to do this. Alright, now in 11 here, it says the tangent of 30. So now we need a right triangle with a 30-degree angle. So it has to be a right triangle. It has to have a 30-degree angle. So by default, that angle is going to be 60. So we just have to have side lengths that would make sense for a 30, 60, 90 triangle. Alright, and since they're all similar, all their sides have the same ratios. So like, let's say the short leg was 1 unit long. The hypotenuse would have to be double it. And remember, that's because we could draw another 30, 60, 90 triangle right here that's congruent to that. And together it creates an equilateral triangle where all the sides are 2, 2, and 2. And then if you did the Pythagorean theorem with those sides, you'd get that side's root 3. So the tangent of 30, according to this triangle, which is similar to all other 30, 60, 90 triangles, so no matter which 30, 60, 90 triangle we use, we get the same answer, is going to be opposite 1 over adjacent, root 3. So that's an acceptable answer. If you rationalize it, you get root 3 over 3. So that's a better answer because it's simplified. Alright, and then if you put it as a decimal, so if you typed in the tangent of 30 on your calculator, you would get 0.577, which is equal to this number here as a decimal.